Hi, in this video we are going to talk about derivative and derivative as a rate of change. First of all, remember that practical meaning of derivative of a function is the instantaneous rate of change of a quantity given by f of x. So, well, it all starts with average rate of change idea. So, the average rate of change of a quantity given by f of x between x equals a and x equals b is actually changing the quantity f divided by changing x. So that's equal to f of b minus f of a all over b minus a. And when you look at the graph of the function, you this expression, this average rate of change expression between a and b also corresponds to the slope uh, of the line connecting the points a f of a and b f of b, which are both on the graph of the function f of x. So average, like if we just take 2 points a f of a and b f of b, the slope of the line connecting them also means the average rate of change of f between a and b. But instantaneous rate of change of a quantity given by f at the point x equals a is, remember, it's the slope of the tangent line. So we take a secondary point, which is xf of x, but our point is actually af of a. So the secondary point is on the graph also with coordinates x f of x. So we take the limit as x goes to a. So we make the second point x f of x get closer and closer to our point a f of a. Then the slope actually, which starts as like an average rate of change, becomes the instantaneous rate of change. So the slope of the line between the 2 points becomes the slope of the tangent line, which also can be seen as the average rate of change becomes the instantaneous rate of change at the point a f of a. So here is one example. This actually example is about one of the very commonly used function, position function. So a particle is moving along a straight line with the position function given by t squared plus 4t plus 10, where t is time in seconds and s is the position in meters. So here are some questions. Find the average velocity between t equals 0 and t equals 2, and then between t equals 1 and t equals 2, between t equals 2 and t equals 3, between t equals 2 and t equals 4. And finally, find the instantaneous velocity at t equals 2. So velocity here means rate of change because remember position function, and we have position function. If we look at the average rate of changes, we actually find velocity there, average velocity. So the average rate of change between 2 and 0, we just put 2 and 0 into the function. So when we do the computations, we find 6 meters per second. If we look at the average rate of change or the average velocity between 1 and 2, that means we put 1 and 2 into the position function. So we do the computations and we get 7 meters per second. For the average velocity between 2 and 3, the computations give 9 meters per second. And for the average velocity between 2 and 4, the computations give 10 meters per second. So then we can give actually an approximate answer to the instant velocity, the instantaneous velocity at t equals to. Well, how? Just by looking at the velocities from the left and the right of t equals to. So they approach to a value between 7 and 9, and taking the average, like between 1 and 2, the average velocity is 7. Between 2 and 3, the average velocity is 9. So if we take the average of these two average velocities, like 7 plus 9 over 2, this 8 is actually the instantaneous velocity because those two average velocities are like the best approximations with these computations. There is another example. Let's say we have a company which produces tables, and the cost of producing X many tables is C of X dollars. So, first part, what is the meaning of the derivative here? What are its units? And So the meaning of the derivative here is the instantaneous rate of change in the cost when producing X many tables. And the units of the derivative is given by, like derivative is the limit of C with respect to X. So, well, that's actually kind of like average rate of, it's like the instantaneous rate of change, which, the units of cost is dollars and units of X is tables. So if we divide them, we will have the units for the derivative, which is dollars per table. So here's another question. In practical terms, what does it mean? C prime 2000 equals 7. Well, it means that when the company produces 2000 tables, the cost of producing is $7. Or you can also see it like the cost of producing the next table, which is the 2000 first table, is increasing by $7. But you can also see this too, like after having produced 2000 tables, producing the next table, which is actually 2000 first table, it's going to be $7. Okay, and C part. So which should be greater, like C prime 20 or C prime 2000? This is actually going to the economics. So like if you think about the cost functions, if the production increases, you know that your cost per your like table will be decreasing. So we expect the cost of producing more tables. Of course, it will increase, but it will increase at a lower rate. Because when you produce a new table, of course you have some costs, because first you have to pay for the raw material, you have to pay for the labor and all the other like electricity and stuff. But it will increase at a slower rate. So when you produce more, C prime 20 will be bigger than or equal to C prime 2000, which should be both positive. Okay, so this is the end of the video.